Right, so in this video, I'm gonna go over part two, find a delta using a graph. All right, so excuse me. Um, let's see that the statement if x minus a is less than delta, then f of x minus L is less than epsilon, means that f of x lies in the inner L minus epsilon, comma L plus epsilon whenever we choose the x in that interval. But x is not equal to a. Yeah, so because there is absolute value here and here, so we could express the inequality as the interval like that, right? So now here's note. We say that the interval a minus delta, comma a plus delta is a symmetric about a because a is the midpoint of interval. So, but we don't always get symmetry in a verb. So let's take example one. So I use a graph to find the number delta such that if x minus 1 is less than delta, then f of x minus 2, this is f of x, this cubic polynomial, and minus 2 is less than zero point 0.2. So number 2, that is L, and the zero point 0.2, that's the specific value for epsilon, and we need to find out delta so that that inequality will be satisfied, right? So yeah, so probably you could find out delta using the way we covered here in step one and step two-step process. So, but let's see. We want here I want us the figure out the delta using graph. Okay, so it means that find delta that correspond to epsilon zero point 0.2 in the definition of limit for f of x is defined by cubic polynomials, and then a is 1, L is 2. All right, so what we're gonna do, start from the absolute value of f of x minus L right there, less than zero point 0.2, and then we gonna simplify the quantity inside of inequality, and then the before doing that, sorry, we're gonna express this one as the compound inequality, which means that the absolute value less than zero point 0.2 means that you know the x cubed minus 5x plus 6, this is between 1.8 2.2, right? So adding 2, I mean taking out the absolute value, then we're gonna get the left inequality, which is negative zero point 0.2, and then adding 2, right? So just do algebra. So we need to determine the value of x for which the chord, the cubic polynomial, lies between the horizontal lines, y is 1.8, y equals 2.2. As you can see that right there. So that f of x is bounded by 1.8 and 2.2. It's not symmetry, right? So right here, this is a graph of f of x, cubic polynomial. And right there, the L is a 2, right? So, and then the which one? X approach 1. So we want to figure out the inner near the 1, so that f of x minus 2 is within, lies within zero point 0.2, right? So here's a 2.2, here's a 1.8, which means 2 plus epsilon and 2 minus epsilon, right? And now what we need to do, so we need to find out, um, see right there, we need to find out the x value whose f of x, the function value is 2.2. So we need to find out the x value whose function value is 1.8, right? So we measure the distance from the 1 to the left end point, which is right here, and the right end point. Okay, so 1 minus delta, the 1 plus delta, right? So then, and the respectively. So, but we know the distance, right? It's right there. Give me a second. Yeah, so we'll figure out the distance from here to here, here to here. Okay, so we choose delta to be smaller. Sorry, let's see, delta to be smaller of this number. That is delta is 0.089, and then we can rewrite our inequality as follows right there. So okay, so if as a value of x minus 1 is less than 0.89, then f of x minus L is less than 0.2. This means by keeping x within 0.089 of 1, we are able to keep f of x within 0.2 of 2. So how can you figure out the 0.089 and 0.124? Because we using the graph, so since we figured out 1 minus delta 0.911, I mean left end number, left end point, and then 1 plus delta, which is 1.124, right end number, point by graphing. And then now we figure out the distance between the left end point to the 1 and the right distance between 1 and right end point, which is a 0.124. Now, so since this is not symmetric, so and then we want to express the epsilon the limit using in terms of epsilon delta, then we have to choose one of them. Then we have to the smaller one. Why? Because in the smaller one, then whenever x is within the 0.08 the inner bounded above 0.089 and below the 0.089, 1 plus 0.089, then that guarantee that what the f of x minus 2 is less than 0.2. So we have to choose a smaller one. Okay, so this is how to find out the delta using graph, but um, in general, we prove the limit using that two steps process. Okay, the procedure, I mean. Okay, keep in mind this. So here, the reason that we use the graph, uses the graph to find the delta in this problem because this is not symmetric. Okay, but normally the problems for proving the limit, that both inner must be the symmetric. Okay, so that's for this video. Okay, so let me stop here.